For this project for ECE 5831 Pattern Recognition Neural Networks, we made a fake news detector. The teammates were Korde and Krina Trivedi. For an outline, we'll start with the project introduction, then go through some literature review findings, as well as the dataset preparation, pre-processing, and then covering two different model architectures, one for CNN, a second for RNN. Then we'll go through the training results, the k-fold validation results. The test demo will be covered in a separate video, and then we'll wrap up with the discussion and next steps. The motivation for our project was to detect fake news articles from true news articles. Fake news articles spread misinformation, and political fake news can even influence voting. During the 2016 presidential election, up to 60 million bots were active on Facebook. But the detection of fake news can be a challenge. In a survey of 83 social media users, only 17% of the participants could detect fake news better than chance. So, a tool that could help identify fake news more often could help prevent the spread of misinformation. In this project, we developed a fake versus true news detector with two methods, CNN and RNN. Then we compared the accuracy and loss results. We found that the CNN model performed better. Then we confirmed the CNN performance with k-fold validation. We reviewed 3 papers in a literature review. The first covered a bidirectional encoder representation and CNN hybrid model. The fake news detection framework, called MCRED, was a fusion of output from transformers and CNNs. The transformers capture the global text context, and the CNNs capture the local features. Compared to other models, this resulted in a 1.1% improvement in accuracy. The researchers also found through model tuning that the atom, ReLU, sigmoid, and binary cross-entropy loss were optimal for producing the best results. We also used the same types of layers and hyperparameters for our CNN approach. In another paper, researchers created a fake news detector with a bidirectional RNN with LSTM, or long short-term memory. This extracted the text features, and the LSTM cells prevented jumps in the gradients. It also retained the context of the words relative to each other. This also has a benefit because RNNs can be used for natural language processing and future word prediction. In the third paper, researchers tried a hybrid approach combining the RNN and CNN. They combined the bidirectional RNN, or the bi-LSTM, and the CNN for text classification of large-scale news text. They follow the steps of text pre-processing, feature extraction, text representation, and then classifier training. With the bi-LSTM layer, the word vector was trained by Word2Vec, which is a TensorFlow model used for learning word embeddings. The bi-LSTM layer also considered the forward and reverse order semantics and stored the words in left and right contexts. Then they applied a linear transformation to a tan-H activation function, then a max pooling layer, and finally a softmax function to produce an output probability for the text classes. This resulted in a model with accuracy of 96.45% and a loss of 0.11. Compared to the CNN with 95.61% accuracy and a 0.15 loss, this showed a lower loss value with the hybrid approach. It also retained more of the original text context and contained less noise. For our project, we proposed combining our models from the CNN and RNN studies as a next step. To start our project, we collected data from Kaggle. We started with the fake and true news data set, which included over 20,000 true news articles and over 17,000 fake news articles in a CSV format. We found some patterns in both sets of data, so we did some cleanup. For the true news data, we found that every text article began with a city name and Reuters. For the fake news data, we found that every article ended in photo by and then a name. So we moved this in order to have clean data for our project. And due to time constraints, we limited this to 3,000 true news articles and 3,000 fake news articles.
In the process of data pre-processing and encoding, there are 10 steps that we have followed. The first one is we try to load the fake and true data set, CVS files. Then we have added the column, we have encoded the column having the label as in 0 as in fake and the true as in 1. Then we remove the unused data for the title, subject, and date. Then we combine the data into the one data set. Having those combined data, then we shuffle the rows and assign the splitting value between the 0 and 1. Once we get the splitting value, we decide to do the split based on the 70% for the training, 20% for validating, and 10% for the testing. So we ended up like having the trained data set for 69.77% of the data, which contains 2,130 of true and 2,056 of the fake records. Now the next one is the validation, which contains 19.85% of the data, which ended up having 595 true records and 596 of fake records of the articles. The test also having a 10% of the data set, which ended up having a 275 true records and 348 of the fake records. After converting these articles into the different data sets, we now converting it into the text to the string. Then we provide the vocab for each string to encode, as in one hot encoding having the vocab size as in 10,000 and max length of 500 words. Then we apply the padding to this particular data set to change array size to the longest article by adding zeros if needed. So in the CNN model, we use the Korde sequential model. Sequential model work like stacking the layers sequentially one after another. The first one is the embedded layer, which converts the input data into the dense vector of fixed size. Over here, it is the 8. Now the conventional one-dimensional conventional layer, which take the inputs of 128 features filters, and 5 would be the kernel size over here. This layer scans through the input data and applies the conventional operations. The activation function is ruler over here. Now the global max pooling layer. This layer reduces the dimensionality of the input by taking the maximum value over the time dimension for each filter output. The last one is a fully connected dance layer, which has the two separate dance layers. The first one, it is connected with the 10 neurons and a ReLU activation function. This layer is used to learn more complex representation of the data. The second dance layer is the one neuron, which is having a sigmoid activation function that works as in a final prediction and giving the output between the 0 and 1. Then we applied the compilation to it using the optimizer Adam, which provide the dimensionality accordingly, and having the loss function for binary cross entropy, and the matrix is the accuracy one that we measure the accuracy based on the evaluation.
For the RNN model, we started with a Keras sequential layer, which stacked the layers sequentially. Then we added an embedding layer, which picked 64 features and tried to fit to the vocab size of 10,000 words. It also ignored any of the zeros that were added in the padding. Then we added a bidirectional LSTM layer with filter size 64 that returned the sequences. Then we added a second bidirectional LSTM layer of filter size 32. Then we had two dense layers. The first dense layer, the 64 fully connected neurons that were calculated with the output based on the ReLU activation function. Then we went to one final dense layer with one neuron output. Finally, we compiled the model with the Adam optimizer and the binary cross entropy loss. This was used due to the binary output. Then we used the accuracy as the metric for the model.
So Here is the comparison between the CNN model and RNN model. Both the model used 20 epochs and batch size of 16 for the training. So in the training accuracy for the CNN model, it is saying that 100% of the accuracy we achieved, and the validation accuracy is 98.57%. The gap between the training and the validation accuracy become the stable. I can see that over here, due to the stableness, I can see that it's a good fit. It doesn't occur the overfeeding as well as the underfeeding. From the records, we found that in the confusion matrix, we found that 585, those are the actual true predicted articles, and 588, those are the actual fake predicted articles. Now in the RNN, we can see it has the same epochs and batch size as the CNN model, but the training accuracy is little bit less than that. It is 99.92%, and the validation accuracy is having at 97.73%. So over here, loss having a little bit fluctuation, which from this we can see that it might be there is some overfitting that have taken place over here. In the from the confusion matrix, we can say that 582 are the actually true predicted articles, and 581s are actually fake predicted articles. From both of the models comparison, we can say that the CNN model having the better performance and better accuracy than the RNN. So in the k-fold validation, we decide to go with the k is equals to 5. Here we're splitting the data into the 5 sets, having so it running like a loop where it take the 4 out of 5 as a model training, and on the one it tasting, it validating basically. So it run through 5 times, and so each and every data point it gets trained and validated. So that's how we get the more accurate results, and it prepared the data with the one hot encoding. So here are the accuracies for the training results. Here we can see that the CNN having a 97.13%, which is the higher accuracy, compared to the RNN, which is having the accuracy of 79.85%. And the loss is also CNN having the less loss as it has the greater accuracy. So the loss is 11.22%, and at the RNN it's saying 3.12% loss is there.
A demo of the code will be showed in a separate video. So as we showed, the CNN model had better results than the RNN. This was also demonstrated with the k-fold experiments, which were more realistic and included training with 80% of the data for each k-fold. The RNN may not have been the appropriate model to use, since we shuffled the data and then split the data, and we applied the one-hot encoding, which removes some of the words. A dropout layer added to the RNN may help improve the performance. And the RNN model is typically used for next word prediction. We also found that training with the RNN, especially with the k-fold, required more time than the CNN due to the recurrent steps involved. So we have a few next steps proposed. The first is developing the CNN further by adjusting the hyperparameters and comparing the results. Then we could test on more articles to check the robustness of the model. The training and validation data used were from 2016 to 2017 and were mostly political, but the model performance from non-political articles is unknown. We could also expand the model to cover more topics for a broader range of detection. Finally, we could also try a hybrid approach, which is similar to the literature review articles, where we add an RNN to predict key phrases that are used in the fake news articles and the CNN model that we built.